So, a short introduction, which let me share your introduction. So, before we start with this conversation, so Richard is the CEO of Art of Problem Solving, which is an organization based in US, and it trains students in achieving their true math potential. And he's been working towards raising the standards of math education for more than 2 decades now. And I'm really looking forward to having a deep conversation with him and gaining insights into the world of mathematics and a lot of other things as well. So we welcome you, Richard.
Excellent. Thank you so much for inviting me.
And so again, and I was, when I connected with you on LinkedIn, the first thing and the only thing that caught my attention was the about section of your profile, which very neatly mentioned in a line, but actually that said a lot. So I don't know if you remember it or not. Let me read out to you. It said, I develop educational materials for some of the world's best math students. I have a great job. So this was very fascinating for me. So could you tell me more about it, and what is it that you really love about it? And I'm very curious to know how you prepare these educational materials for helping students to become best at math.
Excellent. So let's see, there's a lot to unpack there. Why we do what we do, these students who are highly interested and have very high potential in mathematics are the ones who are most likely to have the biggest impact on the world in the next generation. So if we go 30 years forward and the world is confronting whatever challenges my generation leaves behind, it's going to be those students that we're going to be depending on to solve a lot of those problems. And if you look at a lot of the advances of the last 20 years, most of those were made by geeks. They were made by kids who, when they were in middle school or high school, looked a lot like our students. And some of them were our students because we've been around for a little while. And that's a big part of why we do what we do, is we feel like we're investing in futures of students who are going to have a huge impact on, well, their own futures, but also on ours. So if I get to live when I'm 85 the way my parents did when they were 45, that's going to be because of my students. They're going to take care of me then. So that's part of it. But there's also, for a lot of us, here at Art of Problem Solving, at some point in our education, somebody did something special for us, whether it was hand us a book or talk to us at a summer program, something like this. Something happened in our education that changed our trajectory. And a lot of students don't have access to those sorts of opportunities. So a lot of what we're doing is to try to increase the access to the sort of resources that helped us become successful in whatever we've been successful at. So that's a big part of what we do. I think you also asked there about kind of how we go about building these various resources and materials. One of the biggest guiding lights for us is creating the resources that we wished we'd had when we were kids. And that has worked really well for us because it turns out there are a lot of kids that are a lot like we were when we were kids, which was a long time ago, don't get me wrong. But they have the same sense of curiosity, the same sense of wonder. And I think there are a lot more of those students in the world than people even realize. And a lot more than the students themselves even realize. So it's really important that the students get an opportunity to self-identify as really thriving through these opportunities.
So what you just said completely resonates with us also, because that is how even we started. So by the way, we didn't introduce ourselves. I thought we'll do it later on. So I'm Mosam, she is Garima. We are a husband and wife, we are partners. And so this Uncover Math Genius, before this, we started homeschooling our children. We have 2 children. Our daughter is 11 years old and our son is about 7 years old. So we started homeschooling them in 2018, right? Almost 6 years back, more than 6 years back now. So Garima is from maths background. She is PhD in mathematics and teaching at university. But, such young students, she's never taught. I'm more from, early childhood education side. So I guess when she started doing maths with Ridan, who is our son.
Younger son, yes.
Yeah. So I guess 2.5 or 3 years old.
So that's when the lockdown happened because of the pandemic.
Yeah. We realized that probably we cannot do math with them the way it happened with us. So that is when we started. In fact, Garima started researching and figuring out how to do it, because the way it's been done with us was very, very dry, very, very abstract from the very beginning. So, right, Garima?
Yes.
That's
So I very proudly say that though I'm a doctorate in mathematics, I started learning math now. It was never before that I started learning math. So I very proudly say that, and that happened all because of my kids. By doing it with them, by exactly what you're saying, that creating something which we could not get, but then we could deliver it in the right way to them.
Right.
And I'm also very curious to know what made you name your organization as, Art of Problem Solving? And why not something related to math, since it's, it's a math
Yeah,
organization? Yes.
yeah, there are two pieces to that. So the first piece is why art. In the US, at least, a lot of math is taught as just a bunch of recipes. You learn how to factor a quadratic. You memorize the quadratic formula. It's just a bunch of tricks. So you see the same.
It's worldwide. It's global. It's a global problem.
Right. And what we wanted to teach students is the artistry and creativity of mathematics, because most of the most creative people I know are mathematicians. They have to create something out of nothing. They take a few basic rules and then they can create these these beautiful, wonderful, complex, and rich conclusions from very, very simple rules. That's an act of creativity. And that's not something that people associate with math. So that's part of the art. The problem solving piece is that we don't think we're teaching math. So when I'm teaching students, yes, we're using mathematics as a tool, but what we're teaching students is how to solve problems they've never seen before. And that's what we mean by problem solving. And I didn't really appreciate this when I was a student. When I was a student, the only kind of advanced work that I did in high school was in math, preparing for math competitions. But what I found when I went to college was all of my classes that required taking basic ideas and combining them in interesting ways to solve really hard problems, I could handle that coming in the door in college in ways that most of my classmates couldn't. And it wasn't just math, it was physics, it was chemistry, it was engineering, economics, philosophy, wherever I went, I could take these skills into other spaces. And that's why it's art of problem solving, is we're teaching the art of solving hard problems.
So, Richard, we got to know why you started this art of problem solving. It's been 20 years now, more than 20 years, right? So what has kept you going day after day for so long on this?
Yeah, it's a great question. Actually, the original AoPS books were written 30 years ago, so it's even longer. 30 years ago, as I was finishing college, and then I took a detour for about 10 years, and then we came back and built this company. I mean, the kids, they just keep coming, and it's a great thing. There are more and more students to teach. There are more and more ways to teach them, and I think that's something that I didn't appreciate when I started Art of Problem Solving, is the many different ways that kids learn. I mean, it's obvious now that I say it out loud, but and you have children, so you know this really, really well. But I was a book learner. Give me a book, stick me in a corner. Don't put me in a classroom. Don't give me a video. I don't like any of those things. But turns out a lot of kids, they're not your book. You can give them a book, they're not going to read it. There are some who will, but there are many who won't. There are kids who will sit in front of a computer and be really engaged in an online experience. But there are kids who won't be engaged by that either. They need to be in person. They need to be around other kids, or physically around other kids, or around their teachers. So we create environments like that for those students. And even online, there are some kids like this video and audio thing. They need to hear other people. Other kids, well, they don't want to be seen. They don't want to be heard. So you need to find a different way for them to communicate and to communicate with them. So we actually have two different online schools, one that's video audio, one that's text and images, and different students will sort into the different areas based on the work at their own pace. Some students they need a schedule or they're just not going to get it done. So that, I think, is one of the things that has also kept us going, as we keep discovering new ways to talk to students, to reach students, and we find new ways to reach and find new students.
Okay, so I'm sure when you started with this art of problem solving, you must have faced certain challenges that time. So what kind of challenges did you face, and how did you actually overcome those?
Well, we're still working on a lot of those challenges.
I'm sure.
I mean, one. Yeah, I mean, you must know this as you're starting to build something new. Is one of the big challenges is bringing on other people who share your vision and share your mission.
Absolutely.
And that I think has always one of the biggest challenges is to find the people who can contribute in interesting ways. Like you mathematicians, you'll appreciate this. We like to find people when we're adding them to teams, or whether we're adding to the company as a whole, that increase the convex hull of things that we can do. So find people who bring new talents, new skills that allow us to expand in different directions. So like the people who report to me now at Art of Problem Solving, each one is very different from me in some very important way that makes our leadership team as a whole much stronger than if it were just 7 people who were just like me. That would not go very well. And I think that learning that and coming to understand that helped overcome a lot of the challenges early on, is that we need some people with different interests and different skills in order to build out the sorts of things that we wanted to build. Getting visibility and getting people to know about us, I think, is it's an ongoing challenge. I mean, we're pretty big now, but we could be bigger, be reaching more students, and that's always a challenge. We are not. I mean, we're a lot of geeks here, right? Marketing, that's not really something that we're too fluent in, and so a lot of our reach has been through word of mouth. It's through a parent sharing with another parent, or a teacher sharing with a teacher, or a student with a student. But there are a lot of people out there who are not inside the networks of those parents, of those students, of those teachers. How do we reach them? I think that's also a challenge. Getting the broader world to understand the importance of these students and of what they can do. The parents that we work with, they understand it. It's their kids, and there's special teachers who understand it, who can see it. But there are a lot of places where if a student's getting 100 in their math class, that's problem solved. Let's move on to the next student. And that's not a problem solved at all. It's a different problem. It's a very good problem to have, but it is a problem, and a lot of the teachers don't see it. And I think that this really was brought home to me. I got an email from a classmate of mine. I went to Princeton, and I got an email a little bit after I started this company. And he wrote that he got hundreds on all of his math tests in middle school and high school, perfect scores on everything. And he went off to Princeton thinking he was going to be a scientist or an engineer. And he took Math 103, 104, the entry-level sequence at Princeton, and he described it as the most bewildering experience of his life, and it poisoned him on math for years. And this is the problem. I mean, you probably know students who have been through this, or have peers who have been through this.
I completely resonate with what you're saying.
Yeah, and the deep problem here is this student, or he's not a student anymore because he's my age, but his middle school and high school teachers, they probably thought of him as a huge success. Perfect scores on all of his math tests, got into Princeton. That's a real feather in their caps. They don't see the failure that happens in college because he wasn't prepared. It's not his failure, it's their failure. But they never learn it because they want to do well by the kids too. But they never learned that this was not a success. They don't realize that student getting hundreds on all of their tests is going to be held to a much higher standard in college, and they need to be prepared for that. And that's what we're trying to do.
And I completely get it, because the more we talk to people from around the world, we get to know we are all facing same problems everywhere. Like here also, marks is the thing for parents. If a child is scoring well, doesn't matter whether it's a child has really understood the concepts, or it's more cramming and just vomiting it out in the exam. if we see technology and everything has moved so far ahead, but somehow education system, if I talk about schools, you are working with schools, even I worked with a lot of schools in India. So somehow changing them, I feel, is a very big problem. There's a lot of inertia because of a lot of things. There are a lot of factors. And that is one reason we thought that instead of schools, we're working with schools, but reaching directly to parents is also very, very important. That made us, got us into this field. So what in fact, that's absolutely the same scenario over here as well.
So, what do you think? According to you, what is a parent's role in child's education? Since we're touching that sector of the society where we'll be, maybe we are trying to train the parents because we've done it ourselves with our kids. So, I feel we as parents should justify, the child's education. So, what do you think of that? What are your views on this?
Yeah, it varies a lot by age, but I think one of the critical things, particularly as students are young, is exposure to a lot of opportunities, exposure to a lot of spaces where students can find something that they are willing to really invest a lot of time and energy in. Exposing them to spaces where there are other students that are interested in those things. And you said your kids are 7 and 11, is that right?
Right.
So they're still listening to you a little bit. When they get a little bit older, that's going to stop. They're going to stop listening to you and they're going to start listening to the kids around them. So you're also, as parents, wanting to find spaces where the students that are around them are going to help them become fulfilled in whatever it is that they're exploring. So that's part of the challenges of parents, is finding those spaces for their children. For me, in middle school and high school, is math competitions. That's where I found my people. Most of my closest friends now, and I'm 52, so it was a long time ago, but most of my closest friends now are people that I met through math competitions. They were my competitors and rivals in the beginning, but they became my friends and they're still my friends. So I think that's important, is to find spaces with other kids where they can share those interests and start to build a sense of community. But there's another side to this, and that is you want to put your students in these opportunities, and you may need to force them the first few times, because anytime you do something new, it's hard. You're not very good at it, and nobody likes failing. So some kids will resist the first few times. So you're going to push as a parent, force them to go. But at some point, you need to take no for an answer. So at some point, the student's going to be like, "All right, 4 years of violin is enough. Can I please do something else?" And at some point, the parent they have to say yes. And part of the reason that's so important is the real limiting factor for a lot of students. It's true here in the US. My guess is it's true in a lot of places in the world. The limiting factor is time. And a lot of students are spread far too thin across too many things, and they're not able to really invest in one thing, one or two things. And that investing in one or two things, that's where students learn how to really excel at something. And that's the transferable skill. If you learn how to really excel at one thing, well, in 4 years, you're going to need to excel in something else. Well, now you know how to do that. You know that the first year's rough. You're going to be pretty bad. The second year, that's going to be pretty bad too. But by the end of the third year, it's going to start to make sense. And I'm 20 years into being a CEO, and it's almost starting to make sense for me now. And that I think is why you want to create time and space for students to be able to go really deep in a few different areas. All the homework, everything that I was, all the reading that you're going to have to do for the whole semester. And I would work through all of it in the first 3 weeks. I wouldn't understand much of it. But then I worked through it all again in the next 3 or 4 weeks, and then all of it again in the last 3 or 4 weeks. And by the end, I had seen the most complex, the most difficult ideas 3 times. So that when you get to the finals at the end, where you're kind of culminating and getting to the really hard stuff in a course, it was my third exposure spaced out over 11 or 12 weeks. For a lot of the other students, it was their first exposure. And so they're looking at me like, "Oh my goodness, you just understand this stuff." And I'm like, "No, not at all. I've been thinking about this for 8 weeks. It didn't make sense the first time. It didn't make sense the second time. It's starting to make sense the third time." So, but in order to do that, you have to love what you're doing. And you can't force yourself to just cram your weight in and do it. You can do that for a little while, but at some point it stops. And this is part of why I suggest exposing your child to a lot of different intellectual interests so that they can find the one that they're going to do Saturday afternoon when they're not being forced to do anything. And they're like, I was working on this interesting problem, or I'm going to write, I've got this project that I've been working on for 4 weeks, and that's what I want to do instead of playing a video game. When they're choosing something over video games, then you've won. I don't know how you beat video games, but if you find something that beats video games, boy, there you go. You've done something really special. So I think that's it.
Somehow I have this in my mind that probably maths is something we all have. That's very natural to, as a human being, it's like we are rational beings, we are, logical beings. So maths is something which is inherent in us. That's my belief. But what happens is that probably it's not worked upon properly, and that is why, it remains suppressed or it doesn't come out properly. And also, I also feel that the way, it's happening in school systems, that puts a lot of children, away from maths at a very young age, because that disconnection starts coming in. What are your thoughts about it? Do you feel the same way? Yeah.
Yes. I mean, I would go farther in talking about math. When you say it's fundamental, it's also universal.
Yeah.
When we finally interact with, if we interact with an alien species, we're not going to talk to them about our literature. We're not going to talk to them. We probably will not even talk to them about our science, because the models we use to describe the world will be different from the models they use to describe the world. The first thing we're going to do is we're going to talk numbers. We might talk counting, we might talk primes, we might talk pi, whatever it is. The first way we're going to communicate that with them is through mathematics, because that is universal. So, whatever your culture is, whatever your background is, the number we call 1 plus the number we call 1 is the number we call 2. And that isn't going to change anywhere. So it is this universal truth that is underpinning all of the scientific models that we build. The scientific models themselves, by definition, are wrong. They're models. But the mathematics is not. The mathematics is not incorrect. And that also is why it's such a powerful tool when we're teaching kids problem solving, is they get the feedback mechanism. They learn, and they learn that they've learned. They know right away, oh yeah, this is the right answer, this works, I understand this. And you don't get that in writing, you don't get that in other things. But where we fail in early elementary education, probably all throughout a lot of schooling, but particularly in early elementary education, is when we think about how kids learn and like how your children learned, they learn the same way we all do, through a lot of failure.
Yeah.
When you're 4 years old, you see adults doing these amazing things. They're chopping vegetables, they're riding a bike, they're shooting a basketball, but you can't do it because you're 4. But you're going to try because you see them doing it. You want to do it, and you try, and you fail because, well, you're 4, and you can't do it because you're 4, and you cry, you quit, you throw a tantrum, but it doesn't last very long. You come back in 5 or 10 minutes and you try again because you're 4. And you haven't learned yet how to quit forever. And we teach kids how to quit in elementary school.
Yes.
We shouldn't do that. We teach kids in our math classes that the goal is to get it right every single time. And that is not how they learn about the world. They learn about the world by doing things that they can't do over and over and over again until they finally get there, kind of, and then they find something else that's more interesting and they try that too. This is what we should be doing in math class. There's some things they need to get to very high proficiency on, but they don't have to be perfect in their multiplication tables before going on to messing around with geometry. And we need to continually confront students with interesting challenges, just the way the whole world confronted them with interesting challenges when they were 4. And that's what we need to keep in our elementary school classes.
Garima, you can probably, when you were talking about this, suddenly, my daughter came in front of me, and I remember she was learning crochet some time back. She just picked it up from internet and thought, let me try it.
Wow.
And she can do it. And my mother, we live together. So my mother knows crochet. she came to her dadi, her grandmother, and asked her how to do it. And dadi was teaching it. She couldn't get it. She started howling, I can't do it, and all that. And next day, she again came back. And now she's making her own soft toys and everything.
She
That's
started with a
the
new
journey.
channel where she's selling stuff.
Beautiful.
Yeah. And we've seen it so many times happening in front of us. If Ridan, he started writing counting numbers when he was 4 years old. So Garima would tell you he started writing. We thought he'll stop somewhere. Every day he used to write some numbers. We went on a vacation. He took his notebook along. He used to keep writing over there also. And in, I guess, 2 odd months, he wrote till 3 lakhs, which is 300,000. So, and I was wondering when will he stop? So I asked him, so what is your plan? When will you, I didn't ask him, when will you stop? I asked him, what is your plan? How long would you want to go? So he said, Papa, I want to do 1 million. And I was thinking inside me what should I tell him, whether to continue or whether to stop. But somehow after some time, I guess he probably got bored of it, and 3,50,000 something, he stopped himself and moved on to something else.
Yeah, you could teach him about a for loop in programming, and then maybe he'll lose interest in writing all the numbers.
And kids, given they have time, they do all these things. But that is missing. And I completely, resonate with you on this, that they need to have time. We've stuffed so much at such an early age for them that they don't get time to, do things what they want to do.
That's right.
And
that's right. And it just gets worse as they get older.
Schools are so tightly packed that they don't even get time to think certain things. Yes.
Yeah.
So coming back to the math education which we're talking about. So in our experience, whatever is taught till grade 10 can be easily covered in, a much lesser time, for maybe about, 2 to 3 years maximum. And I'm sure you'll understand very well why we are saying this. So because math is supposed to be a very hierarchical subject, and very limited concepts it has till grade 10. And basically, you see the same mathematical concept being taught over multiple years. The complexity is just that the complexity is just in the numerals rather than the concept. So what are your thoughts on this? Because everything is so logical and all these concepts are so much integrated in our regular day-to-day life. And why is this subject stretched so much?
That's a great question. I don't have a great answer for why it is stretched so much. I mean, one reason might be in a lot of places the students are. Summer is one reason. You have 3 months of not doing any math. The kids, in 9 months they learn, and in 3 months they forget. So I think there's some explanation there. I think there's also an explanation in some places where kids are moving from school to school. Teacher starts with the class. They've got, half the students weren't in the school last year. The teacher has no idea what they did in 4th grade, and now they're teaching 5th grade. So they're going to have to review. The classrooms are designed to the accountability, at least in American classrooms, there's a set bar. All the students have to get above this bar. That's how accountability is defined here. So students who are near that bar get a lot of attention and a lot of investment. Students who are far from that bar, in either direction, there's not a very strong incentive for teachers to invest more of their time, or schools to invest more of their time in those students. If they're getting measured, here's the bar. How many students, meet state proficiency? So a lot of the investment is right around that bar. And I had this. And the bar's fairly low. That's also important. One of my colleagues here at Art of Problem Solving, he grew up in China, and he went into math education and came to the United States when he'd finished undergraduate. And he was interested in math education because in China, a lot of the work in China, I guess the PISA is graded from 1 to 7, something like that. And a lot of the work in Chinese education is focused on trying to get the 4s and 5s up to 6s and 7s. In America, a lot of the work is trying to get the 1s and 2s up to 3 or 4. And that, again, is part of what we're talking about. Like, if that's your goal, is your primary goal, and that's a worthy goal. I don't want to say it's not worth doing, but there are other goals in education. We'll talk about that in a moment. But if that's your primary goal, then you're just going to have to keep reviewing and revising, because by definition, those 1s and 2s, something failed them. Something failed them, and you're just trying to go back and find the thing that failed them and fix it and fix it and fix it. We have actually had some success with a couple schools here in the United States for that problem. There was a school in Albuquerque, New Mexico, that just as an experiment, they took their remedial 6th graders, and instead of giving them a remedial 6th grade curriculum, they gave them Beast Academy level 3. And it was much more successful. The kids were more engaged. They felt like they were learning. They were doing better. They felt better about mathematics because it was, it wasn't being pounded on them as just do this problem again, do this problem again, do this problem again. They were given engaging, enriching materials that were at where they were mathematically. And that worked really well. So I think one of the failures in education here has been American education is designed to produce literacy for everyone in a certain set of subjects. Now, we can argue about how well they're even doing that, but they're missing the second pillar of education. So I think one pillar is broad-based literacy, whether that's reading and writing, basic arithmetic, balance your checkbook, compound interest, the things we want everyone to know, probabilities, basic probabilities. And then there's another strand, which is deep mastery. And not everyone needs deep mastery in everything because not anyone can get deep mastery in everything, but we'd like all students to have access to avenues for deep mastery in those areas where they're capable and interested in achieving that mastery. So 2 things we'd like an education system to do. Most of the education system does not do this second thing until well into college. And we need to do it much, much earlier.
And also, do you think it is also because of the way curriculum is designed, or the way probably the math itself is taught in school levels? I don't know much about US, but in India, we strongly feel that is one of the major reasons for children going away from mathematics. It's abstracted too early.
Yes.
We completely understand that abstraction is also the beauty of it, because then you can expand it to anywhere and any level. But abstracting it too early makes it very, very, dry for kids and very, very unrelatable for kids. And that is what makes them, move away from mathematics.
I think, Matlab, with my experience as a teacher, as a lecturer, I feel that, kids as early as when they're in grade 5, when they encounter fractions, that's when they start dissociating from the subject because they're not able to see anything around. The only thing they know is that they have to, you have to talk about fractions from a pizza point of view. That's it. That's the only thing they have in mind. So the dissociation starts happening then and there. So, yeah. So it's a kind of love and hate relationship with mathematics in that case.
Yeah, it's fun that you mentioned fractions. Like whenever I was working with a student who was struggling with algebra, their problem was never algebra. It was fractions. It was always fractions. I mean, one of the challenges with fractions, like you said, the only thing they understand is the pizza, because that's the only thing they're shown. And trying to get students to understand that a fraction is a number. That 1/2 isn't a 1 and a 2. It's a number. It lives between 0 and 1 on the number line. It is a number. Right. And starting there instead of starting with a graphical representation of something that's not a fraction but is a ratio, and you start to blur those concepts when you're introducing them. Oh, now you're really in trouble. I think when you talk about abstraction, like there's a rich area of math that most kids don't see until some don't see until college, if they see it at all. But discrete mathematics, counting problems, basic probability problems, and it's not taught much because it's not taught much. Most teachers don't know this mathematics, so it's hard to get them to teach it. But discrete mathematics is the language of computer science, and that's kind of important. It's the language computers speak, and we're all going to work for the computer someday, so we need to know their language. But it's also like we start teaching discrete mathematics concepts in elementary school, and then we start to go fairly deep into them in middle school. This is before we're doing much sophisticated with algebra, way before trigonometry or calculus. And it is part of what's really nice about it is it's discrete, it's tangible, it's 1, 2, 3.
Yes.
And students intuitively understand those things because they can relate to them. How many ways can you sit around a table? Well, my friends and I sit around a table. I can think about that. I can understand that a lot more than, say, graphing inequalities, which why do I care about graphing inequalities? Well, I can make this optimization problem. Oh, now I'm confused. So yeah, I definitely agree that there's a lot of relatable, interesting mathematics that we can bring earlier and show that the subject is richer and that the kids can get their hands on.
That reminds me of a recent, experience with my daughter. So I was just going to drop her for her class, and wherein she asked me, "What are you teaching? What do you teach in math in college?" So I was teaching discrete that time. So she generally asked me, "What is it?" So I started asking her questions. She got so engrossed with it. Mama, keep asking me because I really find this interesting. But then we're not taught these things. Now she goes to for her class. So she said that I've never been introduced to this part of maths also. So that's when I realized that discrete maths, something which is taught in higher classes, can be taught in early, in your primary schools as well.
Absolutely. Absolutely.
One more thing which we keep discussing, in fact, Garima has, we've spoken about it, Garima has spoken to me about it so many times, is that what children really get confused in when, you give them problems, and same problems with longish numbers, they get confused. But same problems you give small numbers, which they can probably see in their head, they are able to solve those questions. And a lot of times I've seen Garima saying it to parents that the calculations are not important. Numbers, complexity of numbers is not important. Give them simpler numbers, make the problem more complex.
Yeah, I think one of the key things to do here, and this is something we teach with students, is whether it's giving them large numbers or giving them fractions in problems. And what we teach students to do is, you're confused what to do, make up a simpler version of the same problem. And one of the ways to do this is just put simpler numbers in. Right. They put the simpler numbers in. Okay, instead of 5,321 and 7,263, I put in 5 and 7, and I'm supposed to add these numbers.
Yes.
Oh, now I know how to solve the harder problem. So what we're teaching there is a key problem-solving strategy. We're not teaching them, in this kind of problem, you add the numbers. We're teaching them, you see a complicated problem, map it to an easier problem. You solve the easier problem. Now you understand the harder problem. And then you start to build these bridges. And that's where the abstraction can come from, is you start to realize, the numbers don't matter. But it's instead of only giving them the problems with the easy numbers, you want to still show them some problems with the more complicated numbers, but empower them with the strategy of saying, what does this look like with 5 and 7? Oh, wait, this isn't hard. I already know how to do this. So now I know how to do the hard problem too. And that's a strategy they can take elsewhere.
Absolutely.
This is very important because in the present age when, the calculators are everywhere, you just can add, multiply, anything. So it's just that you should not be concerned about of course, solution is important, but the way it is approached is very important.
So what do you... It's a very relevant question, which we find a lot of parents asking, especially in homeschooling community, not school going children. They ask that many of them don't take maths very, very seriously, because for them, whatever children want to learn is fine with them. So why do you think? Because we feel that maths is really important as a skill, because it's not just an academic skill, it's a life skill. It's everywhere around us. So what do you think is, how important is maths as a subject?
I mean, for one, obviously, it underpins a lot of other areas. So if you want to be a programmer, if you want to be a scientist, if you want to be an engineer, it underpins a lot of these things. But it even empowers people in spaces that seem to be nothing about mathematics. If you're a doctor or a nurse and you don't have a really good handle on numbers, you could make some really bad mistakes in the hospital. So you really need to have that sort of feel and not even a deep understanding, but a feel for numeracy writ large. But I think one of the key insights I heard someone share with me once, I was at a conference and there was a woman there who was representing a group that was trying to get various groups into engineering. And the thing that she said that really stuck with me was, you can take math, combine it with any interest you have, and you get a career. So whatever career you're in, if you're mathematically sophisticated or mathematically able, you are going to have a pretty big leg up over other people in that space. Just because anything you do is at some point going to interact with mathematics in some way, is going to require some numeracy, and having that understanding is going to be a very large advantage over people who do not have it. So I think that, and that the other area where this is true is communication. So being able to write clearly, being able to speak clearly, although I think writing is even more important. That's a skill also that translates into whatever space you want to go into. Having that skill is going to really empower you. And we see that here at AoPS. We have people in all sorts of disciplines, right? We have HR, we have IT, we have finance, we have educators, we have engineers. The ones who write and the ones who are strong mathematically, they are more empowered than the ones who are not either of those things.
True, that is so powerful. Take any interest and mix it with maths, or combine maths with it, and there's a career out of it. Absolutely.
Still, people feel very proud in saying that we don't know math.
Yes, right. And would they ever say we're very proud that we don't know how to read? No, they're not going to say that.
Never.
And sometimes we get, when people around us are talking about this, we get furious. It sometimes turn into an argument, because it's become a very socially accepted norm, saying that we are not math people, or I don't know math, which is not a nice thing.
Yeah. You don't want to limit your kids because of things you can't do.
Yes.
Absolutely.
I think that fear, transfers as well. So if the parents are not good with that, they don't have a good relationship with math, it automatically transfers to the child as well.
Oh, kids can smell fear. There's no question about that.
And that is one thing we tell parents a lot. Even if but somehow, whoever you are, like, kids can smell fear. Even if parents don't say it, children feel it.
Yes.
So could you share some advice for educators, basically, on how to encourage the problem-solving skills and how to, deliver the subject in a more engaged and pedagogically sound way?
I mean, I think part of the earlier you start, the better. It's, you heard my college classmates' experience in having this bewildering experience that poisoned him on math for years. The later students have that experience, the harder it is for them to overcome. And the later they have that experience, the less likely they are in a space where it's safe to fail. If you get a D in your first college math class, you're getting you may be hearing a signal that might not be true, but you're hearing a signal that this isn't for you. Like for me, where I got that signal was my first few Olympiad competitions. My first couple dozen practice tests that I took in training camps, I couldn't do any of the problems. It wasn't that I couldn't do some of the problems. There was not a single problem I could solve. But that's a nice, safe space. Who cares if I don't make the US IMO team? I cared a lot when I was 17. I don't care now. But I honestly, by the end, I didn't care that much then either. But like, that's a nice, safe space. But first grade is a safe space too. Who really cares about your elementary school grades, like getting everything right? And I think this is where the educators really have a role to play, is to create safe spaces in their classroom to fail, to not get things correct. So when we're taking our Beast Academy curriculum and building a full classroom experience for it now. And what we learned we had to do when we first started giving the material to the teachers, we didn't give them a framework to understand which pieces of this are essential, which pieces of this are stretch. And that was a failure on our part. But so what we did is we created a framework where we define a set of this. This is core material. Every student needs to see this and eventually get through it. So you really need to work with them. And if they're struggling on this, it's worth your spending a lot more time investing in the kids to get them to understand these core fundamentals. And then there's a set of problems we call the beast problems. Every student also has to see these. Every student has to get exposure to them. And these problems are, they're applying the fundamental concepts, but in novel and interesting ways. And it's ways that can help unlock the fundamentals for some students. So it's not get everything right in the core and then look at the beast. It's, make some progress with the core, see the beast stuff, go back to the core. It's so that the kids can kind of start to put the pieces together. But every student has to see this because it may unlock interest, it may unlock potential, but it's very important to communicate to the students, to the teachers, and also to the parents that the students are not expected to get all of these problems correct. That you spend some time on it, you explore it, you play with the ideas. These are fun. This is fun time. And then after a certain amount of time with it, you move on to the next thing. You don't have to master everything. And this is where we're starting to teach the students, the parents, the teachers that we're practicing here. It's, baseball, you're not going to hit the ball every single time. Soccer, you're not going to get the ball in the goal every single time. These are the problems where you're not going to get the ball in the goal every single time. For the students who can get the ball in the goal every single time, we got another set of problems for them. Those are the bonus problems. And those are going to be even more challenging, but we're not going to show them to every single student. The students who are not ready for that material, we're not going to put them in a space where failure is assured. There's a space where failure is accepted, and we don't want to put them in spaces where failure is assured. And so we learned that we had to create those structures for the educators themselves. So some educators, they might need to create those frameworks for themselves, just to be like, okay, this is the stuff I'm going to make sure everybody can do. This is the stuff I'd really like people to be able to do. I'm going to show it to them, but I'm going to make sure they know it's okay if they don't know how to do all of this, and we can move on. And it'll take a few tries to get the students to accept this. But when you define it as a separate space, the students will come to accept, oh, this is the stuff I need to get cold. This is the stuff I'm going to play with. And it's okay if I don't get it cold. We're going to do something else tomorrow, and that's going to be all right.
Right. When we were researching about you, we also got to know you have books, art of problem solving books, and they are themed on, right? They're based on comic theme. So could you tell me a reason? What was the thinking behind creating books in this theme?
So the reason why we created the comic books, or the reason why we created the textbooks?
Okay, so comic books are different than textbooks?
Yep.
Okay. Yeah. So why comic books?
All right. So this is a fun story. So when we started building our elementary school curriculum, we brought in a man named Jason Batterson to build the curriculum, but we had no idea what we were going to do. So he spent a few months just making worksheets, building outlines, not really sure what is the framework we want to build a curriculum in. And we would get together every couple of days and kick around ideas. And after a few months, in one of these meetings, one person said comic books, and another person 3 or 4 minutes later said monsters. And we're like, this is going to work. And the reason we got so excited about it as soon as this was said, I mean, there are a few reasons. One is we knew we'd eventually be digital, and you don't want to go digital with black and white worksheets. We do have practice books, and we do have practice online, but if it's going to be digital, you're going to be competing with the video games and the television and all of these things. And you don't have to be as pretty and dynamic as those are, but you do have to be at least a little engaging. But the other reason is, in a comic book, well, you have young kids. You know how lecturing young kids goes. It does not work. You need to have a conversation. You need to have a conversation. You need to build a rapport. And that's what we do in the comic books. In the comic books, well, we're not in a room with the kids. So what we can do with these comic books is we can simulate a conversation. The kids in the comic books are talking to each other. They're talking to the teacher. They're problem solving together. They're getting it wrong sometimes, and that's okay. They're questioning each other, and they're working together to get to a final solution. And what happens there is the kids will start to emotionally and intellectually put themselves in those spaces. They will become one of the beasts. They will send us pictures of themselves at Halloween, or the parents will send us pictures dressed up as our beast, or dressed up as beasts that they just made up themselves, because they're now characters in Beast Academy. And by putting themselves in those conversations, they're able to draw the information from those conversations. So that was a big part of why we created these worlds. And then, of course, you also have a rich visual world, and there are some concepts that you can teach visually just much more effectively, particularly to some students, than you can by just writing text or even talking to them.
Right. Right. Math becomes real. And I feel maths is more of a language than, and with comics, I could figure it out that because of those conversations, it becomes even more, relatable for the kids to understand what is happening.
Yeah.
And what do you think in parents, because we have started with the program for the parents. So what do you think parents can do to support their children's interest in mathematics? Matlab, per se, if I talk about math only, math education. So we've talked about the role, but what about how can they actually make interested in mathematics?
Is the question here, how can they make them interested in mathematics, or how can they maintain their interest in mathematics, or a little bit of both?
How to support their children's interest in mathematics?
If you have a student that's already interested in mathematics, you've already won the most important battle, which is getting them to care. Supporting that interest and getting them to not lose interest. Part of it is getting them in social circles with other kids who share that interest. Now, it's important that those kids be somewhere relatively close, whether it's in age or ability or previous exposure to math. Because if you put a student in an environment where they're 4 years behind the other students, that's not going to work out very well for anybody. Every once in a while it'll work, but most of the time that's not going to work. So that's these sort of social spaces can get really important as the students get older. Watch closely to see if they're losing interest and try to diagnose why. So sometimes students will start to lose interest in math because their school is brain-numbingly boring, and you hope to just find other avenues for the student to be exposed to interesting ideas, and they might not be in math. You might expose them to computer programming. You might expose them to science. You might need to go somewhere else for them to rediscover their interest in math. But if they have exposure to interesting math, they're working through Beast Academy, or when they're older, working through AoPS materials, and you see them starting to fade away. There are a few things to look out for. One is the student is burning out. It's just spending too much time and coming to dislike the math or dislike doing the work. I went through phases of this in middle school and high school where I'd work very hard on math, I'd get sick of it, and then I'd miss it, and then I'd work very hard. And that's natural, and the parents shouldn't freak out, the kids shouldn't freak out. Encourage the student to take a break, to pull back, and this is hard for some parents. There are some parents that are just like, go, go, go. And we see this in the major US competitions. There's a middle school competition called Math Counts, and it was the one that launched me as a student. I think it might be the most important extracurricular math program in this country. And what we see in the top 10, 15 students every year in the national competition, we know a lot of these kids. Usually there's a set of these students who got there because their parents forced them to work all the time. And the kids were very high ability. They were high interest at one point. But by the time they're getting towards the end of middle school, and definitely by the time they get to high school, those kids usually quit. They stop studying math. And then there's another set of students whose parents made opportunities for them, may have occasionally pushed them a little bit, but mostly let the kid push. And they're often not the sometimes they're the number one student, don't get me wrong, these students can do quite well. But sometimes, they might be the 30th best student in this competition in 7th grade, but by the end of high school, they're one of the best in the world because they're driving the bus. And once the kid gets to be 16, 17, 18, you have no choice as a parent. They're driving the bus.
Right.
And I think is a critical thing for students to understand in supporting that interest is make sure it remains their interest. And that I once had a parent, this was one of my favorite parent interactions. I was at a math competition. We had our books. This is early days of AoPS, but we had all our books out, we're selling them to the parents. And this father and son come up, and the son turns to his dad and says, I want this book and this book and this book. And then he runs off and starts playing with his friends. And the dad turns to me with a huge smile. And he said, I've been wanting to buy these books for 2 years, but it had to be his idea.
Right.
And I'm like, oh, he gets it. This is going to work. So
I think
yeah.
if the parents are a little pushy, that's when kids get away from. And I think we've experienced the same thing with our daughter also. The more we pushed her into reading, that's when she was losing it. That I don't want to do it. Initially, and then obviously, as a parent, you always learn. With the second child, we were very, easy with whatever he's doing, whatever his interests are, and he always, whenever he gets into the car, he's always like, please ask me maths questions. So I have to be, on my foot every time with him. And when it comes to reading, also, we've never pushed him, and that's when we've just surrounded him with a lot of books, and he's on his reading spree every time. So,
Yep. Make sure the opportunity's there, and every once in a while you may have to nudge a little bit here or there, but
right.
Yeah, there's a limit to how effective that's going to be.
And it happens with all children, I feel. It's just that how much the parent observes that creates all the difference, and act accordingly.
Yeah.
So a question from my side, that what is your vision for the future of math education?
Ooh, I mean, predictions are hard, especially about the future. I mean, I think it's important that there be many avenues, and I think you're starting to see more and more of that. Certainly here in the US, you're starting to see it, and it's not just because the internet allows for there to be more access. I mean, that's certainly a big part of the story. But parents are becoming more empowered in taking control, and students are becoming more empowered in taking control of their own education. And that's important, is for parents to have agency and the students to have some agency in finding the resources that best fit their kids. And I think that trend's going to continue. And part of that's happening here in the US is so many of the top students are finding their education outside the classroom. They're coming to us. They're going to summer programs, specialized summer programs. Now, one of the problems is there are a lot of kids who don't have access to these sorts of things, and we need to work on that problem. I think that's a trend you're going to see continue. I think more divergence, and that's a challenge. Is you're going to see more divergence between those students who have access to these opportunities and those who don't. And the solution we often have here in the United States is remove access from the people who have access, instead of expand access and give access to more students. And I think that's something that we're starting to work with schools as a means towards expanding the access rather than removing the access. But I think you'll see that continue as well. But what math education is going to look like in 20 years, it's not going to look a whole lot different. Arithmetic's still arithmetic. We're not going to change our mind on what math actually is, as much as there may be political forces that try to do that. You can do that in history. You can do that in literature. You can say, okay, we're going to study different things. But in math, arithmetic's still arithmetic. There's only so far you can move.
The way it is taught rather than what is to be taught. What obviously remains the same.
Yeah, I mean, the world is always, you see a lot of people talking about one-to-one instruction and AI and these sorts of things. And it's possible we'll see one of these things work. I think that's still pretty far away. I think AI has gotten to the point where it's pretty strong in really narrow bands in terms of like adaptive learning. But most adaptive learning systems, most adaptive and most AI, they're fundraising mechanisms more than they are pedagogical tools.
Right.
So I think mostly ed tech has to date not been additive in education. And, if you look at US test scores, they plateaued before the pandemic and have started to drop. And I think ed tech is part of the reason. And because it's a lot of ed tech is developed by technologists who are trying to apply their technology to education, instead of educators who are trying to use technology as a tool in education. And I think that's a shift that we need to make in order to develop tech tools that will be more effective. So in AI, I think the I'd say proximate immediate path forward isn't as an AI tutor. I think the AI should be an AI classmate, because the AIs are still not very sound. They aren't always doing pedagogically good things. They're sometimes doing some crazy things, but everybody knows their friend is an idiot, right? So your friend does crazy things. Oh yeah, well, it's my friend. That's what she does. So if the AI companion is a companion instead of an instructor, it's going to be the student's going to have the right relationship with it, the right skepticism towards it, rather than something that's trying to tell you what's correct. That's a short-term view. A longer-term view, one of the other challenges about one-to-one education, like this was a movement for a while in the US, where put all the kids in front of a computers and have the computer teach directly where the student is. First of all, I haven't seen anything yet that can figure out where a student is. But second of all, as soon as you put all the kids on computers in a classroom, they lose the other students. And the point of having a classroom is to bring the kids together. You lose this social space. So I think this has to still be thought through. And I think we're still in early days. We may get to a fascinating place. It's not going to happen quickly because nothing in education happens quickly.
True that. And you very aptly, just stated this, that EdTech has completely gone the wrong way. It's more become a transmitting mechanism rather than bettering the quality of education, which it actually can if right pedagogical techniques are used.
Right. And it can also, technology can be powerful as a connecting mechanism, bringing students together. So, and that's what we've seen in our online community, is students from around the world talking to each other. And many of these students don't have students in their local communities with whom they can share their interest and their love and their challenges in math. But you bring them together online, and now they found their people, and they can go further.
Been a really, interesting, engaging conversation we've had with you. And I just got that pop-up also of only 14 minutes left in the meet. I realized that we've gone, we thought it would be around 1 hour. We didn't want to stretch you also. So it's already gone up. So that's, thank you so much for, accepting the invitation and giving us so much time of yours.
Very much my pleasure.
And thanks for giving us the insights also. Lovely, chatting, having a conversation with you.
I've enjoyed it very much. It's great to find kindred spirits all the way around the globe. This has been wonderful.
Absolutely. And that was the one reason we really wanted to connect to you, getting to know the, people from completely another part of the world, and the education is happening over there. So it's been a pleasure, and thank you so very much.
We realize that mathematics is a global problem.
Yes, very much so. It's also a global solution. So
yes, absolutely. Agree. Okay. Thank you.
Well, thank you both.
Thank you so much, Richard.
Thank you.
All right. Well, have a good evening.
Same to you. Have a good day.
Take care.
Thank you.
Thank you.